Let us solve one problem on Newton-Raphson method of load flow. This problem was asked in GATE 2018. It says that the per unit power output of a salient pole generator which is connected to an infinite bus is given by the expression this. This is the expression for power, per unit power, right? Where delta is the load engine, as you know. So delta is variable here, and this P is depending on delta only, right? Newton-Raphson method is used to calculate the value of delta, this variable, for P is equal to, so this is a specified value, right? If the initial guess is 30 degree, guess of which variable? Variable is delta. So delta 0 is given as 30 degree. Then its value in degrees at the end of first iteration is. So this is very simple problem asked on Newton-Raphson method. So as we have already discussed, in Newton-Raphson method, we know that power mismatch vector. This problem is so simple because of just single variable problem is there. Just one delta. Delta may be one more or more than one, and one more variable V may also be there, but V is not there, and one delta is given. So it is the simplest form of, I think, Newton-Raphson method of load flow. So del P and del Q, power mismatch vector, is nothing but Jacobian matrix J11, J12, J21, J22 and del delta del V. So here Q is not asked, just problem is to evaluate delta 1, this variable. These are variables, right? Corresponding correction is variables. So V variable is not given and only one delta variable is given. Again, Q is not mentioned anywhere. So only P, delta P, you know, difference of specified and the actual one, right? So you know how to evaluate the elements of Jacobian matrix. So J11 is del P upon del delta. What about this? Del P upon del V. So V is not given. So you have to focus on this element only, right? So for this single variable delta, we can easily write for ith bus or any bus where this generator is connected. Salient pole generator is injecting power into the system through that bus. So for that bus, say this is generator and this is the bus and this is remaining part of the system, power system. So focus here, for this bus a specified power is given as P specified as 0.8 per unit. Okay, 8 per unit, and this P is function of, this is P which is a function of delta and which is given by this. So this actual power varies with the variation in delta. The delta is variable and it has been asked to evaluate the value of delta after first iteration of Newton-Raphson method, taking initial value of that variable as 30 degree. So delta 0 is given as 30 degree and delta 1, you know what is delta 1? Value of this variable in first iteration, right? So you have to evaluate this. So take your calculators. So how to proceed? First we will evaluate this del P at the initial value because it is first iteration. So whatever the values of variables are known in any iteration, this power mismatch will be evaluated. Then the elements or element will be evaluated. Then this will be obtained and the corresponding variable will be updated. That is the procedure, isn't it? So what is del P? Del P will be P specified minus P calculated. So this is all calculations in per unit. So this is 0.8 0.8 per unit minus this P. Put this value of P, right? Whatever it is. So I am writing it P delta directly. Where P delta is this. You may write this as P delta, function of delta. So this P delta is this. So this will be equation for del P. What about this? So Jacobian matrix J directly we can write. We will write this only, right? Because we have P and delta only, and this is nothing but del P upon del delta. So you will write del P upon del delta, and P is function of delta. So take partial derivative or directly first derivative, because only one variable is there. So you may write that it will be equal to 1.4 cos delta. Okay, 1.4 cos delta plus 2 is there. So 2 into 0.15, 0.3 plus 0.3 cos 2 delta. So you may write this del P. For this case, what you will write? Del P will be equal to, the dimension of this del P will be 1 by 1. It's not it. And what about the dimension of this? This is also 1 by 1. So the dimension depends upon dimension of P and dimension of delta. So first row is corresponding to P1, del P1 upon del delta 1, del P1 upon del delta 2, del P1 upon del delta 3, and so on. But the number of variable delta is 1 only. In future, there may be more than 1 delta. So whatever it is, that's why I am saying this is the simplest form of Newton-Raphson method based problem. So what will you write? What will you dimension for the present case of this 1 by 1? Is not it? Okay. What will the dimension of del delta? Variable is 1 by 1. So for this case, we will write del P will be equal to J times del delta. Clear to all of you? We know del P, we know J, we know del delta, and again it has been asked to get the value of delta in first iteration only. If even it has been asked after second iteration, even though we can calculate how to proceed. So first evaluate this at the present values of variables, that is delta 0. So this is this. So you can evaluate delta 0 at delta 0. Evaluate this at x0 for first iteration. So you can evaluate this at delta 0. Calculate this. So this will be, so for this case, if we are putting 0, so for first iteration, we will evaluate these two. We know this function of delta. We know this function of delta. So this will be evaluated. Once del delta 0 is evaluated, so corresponding variable will be updated. So how to update? It means delta 1 will be delta 0 plus del delta 0. Tell me the values quickly. So you have evaluated del P0. Del P0 is nothing but, what is del P0? Del P0 is nothing but value of del P at delta is equal to delta 0. So it is single variable problem. If more than one variable is there, then you can make one variable vector, say capital X. So you can evaluate this at x is equal to x0. So what is the value of del P0 now? So this is del P. What is this P delta? I'm getting so how much it is? Okay, I'm writing complete one. So this is P delta, 1.4 sin delta, 1.4 sin delta plus 0.15 sin 2 delta. So you know del P, and delta 0 is 30 degree. Tell me the values.
Minus 1.5, minus 0.15.
Then minus 1.5.
So minus 0.15.
Value is coming out to be
Minus No, sir. The 0.029. No, sir.
Okay, tell me any value. Delta P0. You are talking about delta P0.
Yes, sir. Yes, sir.
So this is coming out to be
0.0299.
0.0299. What is other value? Okay, just this is 0.8. 1.4 times sine 30 degrees half plus and sine 60 degrees root 3 by 2. You have calculator. So can't you calculate this? How much it is coming? Okay, whatever it is coming, tell me the final value of this. Delta 0.
Excuse me, sir. So there is minus over there, 0.15.
Okay, yeah, here, right? Okay, minus is there. Okay, I will write plus only. I will put bracket here. That will be more clear, right? Okay. So this is nothing but P delta. So what is value? Okay, check it at home. And this delta 0 in my calculation, it is coming out to be minus 1.26 degree. Minus 1.26 degree. Just check it, whatever the values are coming. Just carefully calculate it. Concept is same. So this is minus 1.26 and delta 0 is 30. So our final answer will be 30 degree plus, okay, put minus 1.26 degree is equal to, okay, final answer. Tell me the final answer. 28.74. 74 degree, right? Okay, in degrees. Any question? Are you getting the concept behind this problem? Okay, let us solve some more problem. This was asked in GATE 2018. So now we will solve GATE question asked in 2017. A 10 bus power, just write down. I am dictating, otherwise it will take much time. A 10 bus power system consists of 4 generator buses. 4 generator buses, G1, G2, G3, G4. I am repeating. A 10 bus power system consists of 4 generator buses, G1, G2, G3, G4, and 6 load buses indexed as L1, L2, L3, L4, L5, L6. So total number of buses are 10. Out of these 10 buses, 4 buses are represented by G1, G2, G3, G4. These are generator buses, and remaining 6 buses are load buses. Clear? Full stop. The generator bus G1 is considered as slack bus. So this just number it. Okay, right here bus number. Bus number. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 bus system, and it is given that the generator bus G1 is considered as slack bus. So this is slack bus. If not given, even though we know that slack bus will be among the generator bus, generally the highest capacity generator bus is slack bus, but it is given, okay. And the load buses L3 and L4 are voltage controlled buses. L3 and L4 are voltage controlled buses. So it has been L3 and L4 are voltage control buses. It means P is specified. So for PQ bus, P is specified, but once it is mentioned that these buses are voltage control buses, it means V is also specified. So this will be PV buses. So right here, these are PV buses. Okay. Full stop. The generator at bus G2 cannot supply the required reactive power demand. The generator at bus G2. This is generator bus, but it is not capable of supplying the required reactive power, required Q, and hence it is operating at its maximum reactive power limit. Remember the checking a limit of Q, it means limit is violated here. So once limit is violated, so that Q will be equal to the limiting value that has been mentioned here. So maximum means it is not capable of supplying the required. Whatever the upper limit is there, that is not sufficient. So in that case, this bus will be treated as PQ bus. So indirectly, it has been given that, I am repeating again, the generator at bus G2 here cannot supply the required reactive power demand, and hence it is operating at its maximum reactive power limit, full stop. So we can conclude that this has now been treated as right here, PQ bus. You know why, reason behind it. Full stop. The number of non-linear equations required for solving the load flow problem using Newton-Raphson method in polar form is, fill in the blanks here. Repeating again, the number of non-linear equations required for solving the load flow problem using Newton-Raphson method in polar form is. So number of non-linear algebraic equations required are nothing but the dimension of this, is not it, or dimension of this, or dimension of this. So this is column vector, this is column vector, this is a square matrix. So number of rows here will be same as number of rows here, and number of column here will be same as number of rows here, because we are going to multiply these two matrices, and number of variables will also be equal to the number of specified quantities, is not it? Say P is specified for both type of buses, PQ and PV, and Q is specified for PQ. Similarly, delta is variable for both buses, PQ and PV, and this is variable for PQ. So this will be corresponding to number of PQ buses. This will also be corresponding to number of PQ buses. This will be corresponding to number of PQ plus PV buses. This will be corresponding number of PQ plus PV buses. So here also number of row will be same as that. So once number of row is same and number of column is same and number of row of this column matrix is same as that, it means this has to be a square matrix. Clear? So indirectly it has been asked that what will be the dimension of this, because dimension gives the number of non-linear equations to be solved using Newton-Raphson method of load flow, is not it? So tell me how to get the number of this. So first count the number of PQ buses. So this is slack bus, fine. These PQ buses, how many PQ buses? So first count PV buses. These are generator buses. PV is not PV buses, and these load buses are PQ buses. These are also PQ buses. So in this 10 bus power system, first one is slack bus. So out of remaining 9 buses, how many PV buses are there now for the given conditions? So 2 here, PV, and 2 here. So 4. So PV, number of PV buses is equal to 4 here. Number of, and what about number of PQ buses? Just count it, or 9 minus 4 is 5. Just count it, 5, right? 2, 4, 5. Okay, 5. So how to get dimension? As we know, The dimension of this is corresponding to number of PQ plus PV. Because P is specified in both type of buses. So this will be having dimension of 4 plus 5, 9 by 1. Del P will be having dimension of 9 by 1. Is not it?
Yes.
What is the dimension of del Q? So dimension of del Q. So Q is specified in
PQ.
number of PQ buses are.
5.
So it will be 5 by 1. So dimension of this power mismatch vector will be 5 by 1 or and 9 by 1, 5 by 1, that is 14 by 1. So dimension of this will be, for this case, 14 by 1. Similarly, dimension of this will be 14 by 1, as we have discussed. You can count variables also. Based on specified quantities or based on variables, you can get the dimension. So what will be the dimension of this?
14 by 14.
So sometimes it may be asked what will be the dimension of Jacobian matrix. Sometimes indirectly may be asked number of nonlinear equations required. Sometimes it may be asked number of unknowns variables. So what will be answer? Number of equations required will be 14. Are you having any doubt? Still, without no doubt. So this was asked in GATE 2017. One more problem was asked on the Newton-Raphson method in same exam in other set. 2 sets were there in 17 also, 16 also. Last year just 1 set was asked. So just I am writing that equation also. That is also of the same year, GATE 2017. Okay, just write down. Any question in this problem? No doubt. I am rubbing this. Write the statement of the problem. In a load flow problem solved by Newton-Raphson method with polar coordinates, write down. In a load flow problem solved by Newton-Raphson method with polar coordinates, comma, the size of Jacobian is 100 by 100. The size of Jacobian is 100 by 100. This size is given now. So for earlier cases, it was coming out to be 14 by 14. For present case, it is 100 by 100. It means the size of this will be 100 by, the size of this will be, okay, fine. From this information we can write this additional information. Full stop. If there are 20 PV buses, so it is given that number of PV buses is equal to 20. In addition to PQ buses and a slack bus, it is written that if there are 20 PV buses in addition to PQ buses and a slack bus, comma, the total number of buses in the system is, fill in the blanks in there. What is given? Size of the Jacobian is given as 100 by 100. This was also asked in GATE 2017. You can check it, verify it. Just write down the statement and see the questions asked in previous 10-20 years. So it is given that dimension of Jacobian is 100 by 100. Just be concentrated here. A number of PV buses is given as 20 in addition to slack bus and PQ buses. Obviously 3 types of buses will be there. So out of number of buses, whatever it is, it has been asked, find the number of buses in the system. So assume that let X be the number of total buses in the system. So we have assumed this as system. So number of PV buses, okay, here it is given as 20. One bus is slack bus and we have assumed total number of buses as X. So what will be number of PQ buses? Okay, see, first one is slack bus, here we have to write PQ buses, and it is given that PV buses are number 20. So total is X. So X minus this plus this, that will be X minus 21. So number of PQ buses will be X minus 21. So that total number of buses will be X. Is not it? But this dimension is given. So we know how to get, if we know number of buses, so how to get dimension, and vice versa. If we know dimension, then how to get number of buses. So what will be the formula for that? So can we write number of buses, that is 100, is equal to, see, this will be corresponding to PQ, this will be corresponding to PQ and PV both. So for one PQ, one for del P, one for del Q will be there, and for one PV, only del P will be there. So can we write 2 into number of PQ buses plus number of PV buses? We have discussed some other way also to write this. So directly we can write this also, is not it? Because P and Q both are specified in PQ buses. So the dimension will be twice of this. And only P is specified in PV buses. So dimension will be corresponding number of this. So and this dimension is 100 given, right? So we may write 2 into, what is number of PQ buses? Okay, here write X minus 21. X minus 21 plus what is number of PV buses given as 20. So take me the value of X. This implies X is coming out to be 61. Okay, fine. Answer. Any doubt? Are you feeling tough? These problems are tough or easy? How you feel? You are feeling easy? That's good. Okay.
So can you tell me why did you multiply 2 there?
Okay, I'm explaining again. Dimension of this power mismatch vector is corresponding to the number of PQ and PV buses. If one PQ bus is there, it means one P specified quantity is there, one Q specified quantity is there. So 2 specified quantities are there corresponding to one PQ bus. So if 2 PQ buses are there, then how many specified quantities? 2 times of that. So if number of PQ buses are X minus 1, so the contribution of PQ buses in this matrix dimension will be twice of number. What about PV buses? So only P is specified, Q is not specified for PV bus. So corresponding to one PV bus in the system, contribution in the dimension of this power mismatch vector will be corresponding to the number only, directly proportional to the number of only. Are you getting this? If you are getting problem, then discuss with your friends. If you are still getting problem, apply that method, backup method, which we discussed in the previous problem. So we have lots of backup methods also. If sometimes some method is not clear, you can apply backup. But by anyhow, you have to attempt the problem. Once you know the concept, you have to get benefit of that. Right? Clear? Okay. One more problem we will solve. We solved one problem of last year on Newton-Raphson method itself. 2 problems on previous years of that is 2017. We will solve 2 more problems asked in 2016. So now I'm grabbing this. So write the statement of this problem. 2016 set 1. 2 sets were there. A 100 bus power system, in a 100 bus power system, comma, there are 10 generators, full stop. So 100 bus power system, number of buses are 100. number of buses is equal to 100. Okay. There are 10 generators. 10 generators. 10 generators means out of 100, 10 are generator buses. So remaining 90 will be one slack bus is also there. So tell me number of PV buses and PQ buses. Huh? 89. That's why this problem was asked in GATE. Slack bus will always be among generator buses. Be careful. Is not it? Okay. So now the number of PQ buses will be? Yes, is 90. 90? Because, okay, out of 100 buses, 10 are generator buses. So 3 types of buses will be there: slack bus, generator bus and load bus, PQ bus. But you know that slack bus will always be among generator buses, generally the highest capacity generator bus. Is not it? So you may write, okay, one bus is slack and remaining 9 bus will be PV buses, and how many? You are saying 90. Okay, 90 plus 9 plus 100. Okay, fine. PQ buses. Okay, first complete the statement of the problem. In a 100 bus power system, there are 10 generators. Full stop. In a particular iteration of Newton-Raphson load flow technique, in bracket, in polar coordinates. So, it is my observation that everywhere polar coordinates has been asked. Mostly polar coordinates. It is written, you can check from the question bank. Right? In bracket, in polar coordinates, comma, 2 of the PV buses are converted to PQ buses. See here. Repeating again. In a particular iteration of Newton-Raphson method of load flow technique, in bracket, in polar form coordinates, comma, 2 of PV buses are converted into, okay, write this also, this information, 2 PQ buses are converted into PV buses. Okay. 2 PV, right? Okay. 2 PV buses are converted into PQ buses. You know the reason behind this also, but not required. Just focus what is information given here. So 2 PV buses are converted into PQ buses. Forget about the reason, but you know the reason. Full stop. In this iteration, 4 options are there. So I am writing the options. Option A, it says that number of unknown voltage angles. Number of unknown voltage angles, that is delta. Delta is voltage angle, right? It is written in words, so directly I am writing the symbol. The number of unknown voltage angles increases by 2. I am writing this symbol, increases by 2. And the number of unknown voltage magnitudes increases by 2. And number of voltage magnitude is represented by V, is increased by 2. So option A is saying this. Option D is saying number of unknown voltage angles remains unchanged. It is saying that number of delta is equal to unchanged. And number of unknown voltage magnitude increases by 2. Same. C option is number of unknown voltage increases by 2. The same one. Voltage. It is saying about voltage. Okay. So number of unknown voltage is increasing by 2, and the number of unknown voltage magnitudes decreases by 2. It should be delta, I think. Okay. By 2, and this is decreasing by 2. And the last option D is the number of unknown voltage angles remains unchanged. It is saying that the number of unknown voltage angles delta is unchanged. And the number of unknown voltage magnitudes decreases by 2. Okay. So first focus on the information provided. Number of buses are 100. This was the earlier problem. Okay, same. So 2 of PV buses are converted into PQ buses. So write the unknowns for PV buses. Unknown for PV buses. Okay, Q and delta. What are unknowns for this? V and delta. So if one PV bus is going to be converted into PQ bus, so delta remains same, but there is one increment of this variable. So delta remains unchanged once one PV bus is converted into PQ bus. You also don't know the reason behind this, right?
Yes, sir.
But this variable is going to be increased by 1 corresponding to one PV bus conversion. And it has been given that 2 buses have been converted into PQ. So the number of delta increased in delta variable will be 0. Delta remains same. Delta is here also. But this variable will be increased by. So which option is the appropriate option? Okay, B is appropriate. Fine. Just take the options at home, and just we will focus on concept behind this problem. Any doubt? Okay. So one last problem for today's lecture of the same year, 2016. Write the statement of this problem. Data are almost same. This was asked in set 2 of the same year 2016, and the earlier question was asked in set 1 of the same year 2016. So just write the statement. A power system has 100 buses. A power system has 100 buses, including 10 generator buses. The same information, same data of set 1. A power system has 100 buses, including 10 generator buses. Full stop. For the load flow analysis using Newton-Raphson method in polar coordinates. Repeating again. For the load flow analysis using Newton-Raphson method in polar coordinates, comma, the size of the Jacobian matrix is. I am writing the options. The size of the Jacobian matrix is so options are A 189 by 189, B is 100 by 100, C is 90 by 90, and D is 180 by 180. I hope you can solve this problem yourself. Okay, how many are in favor of A? How? And what about others? B or C or D all are coming, right? Only A is coming. Okay, can anyone explain how A is coming?
So we'll be having P variable for both PQ and PQ buses, and Q for only PQ buses. So there are 99 P's and 90 Q's.
So that the dimension will be
189.
how? Just write here. You want to write 2 into number of
P's for
PQ buses.
For PQ as well as PV buses.
So how many PQ buses are there? Okay, we have already evaluated this problem, right? So 90 plus number of PV buses 9. Okay, 9. So this is coming out to be 180 plus 9, that is 189. So dimension of Jacobian matrix will be this by this. and dimension of power mismatch vector will be 189 by 1. Okay, fine. Thank you very much for today's lecture. And just try to solve some other problems also. Still, if you are getting any problem, you can contact me.